Today we're going to look at some key physics concepts, displacement, time, and average velocity. Let's suppose a racer drives along a straight line, and we can describe his motion with this diagram down below, so we can see that the racer drives from left to right here. And we're also going to need an appropriate coordinate system to describe this motion. And the most logical coordinate system is to choose the x-axis to lie along the direction of linear motion. And we also need to choose an origin, so we're choosing the starting point of the diagram. You can see below where we choose the origin. This will be the reference point for where all our values are going to be measured from. So now we have everything in place to add some numbers and determine some values for the displacement time and the average velocity. Let's suppose the following situation. So let's draw the same diagram below, but now we have position 1 and position 2. These are two positions of the car. And then position 1, that's going to be at time 1 second. And position 2 will be at time 4 seconds. And the position 1 will be 9 meters and the position 2 will be 27 meters. So yeah, we have to note that x1 and x2 are relative to the origin. So that's where it's measured from. Below, we'll just show the diagram a different way, showing how the positions are measured from the origin. And we label what time it was when the car was at position 1 and position 2. Now we can properly define what displacement is. Displacement can be described as the vector pointing from position 1 to position 2 of an object. So in the image above, we can show that with the vector pointing from P1 to P2. So in our case, it is change in the value of x. So we can label it as delta x equal to x2 minus x1, where delta x is just a change in the x-coordinate. And it's going to be 27 minus 9 equal to 18 meters. So that would be the total displacement for our situation. Now we can look at defining the average velocity. The definition for average velocity is going to be the change in position divided by the change in time. And analytically, it can be shown as V average equal to delta D divided by delta T, where delta D is the change in position and delta T is the change in time. So we're also going to note that we're going to need to calculate the change in time as well, which is delta T equal to T2 minus T1. And for our example, T2 is 4 seconds and T1 is 1 second, so 4 minus 1 equals 3. So now we have delta x and delta t, and so we have everything we need to solve for the average velocity. So we can start by writing down our formula, V average equal to delta D divided by delta T, where delta D is also equal to delta x in our situation. So it'd be delta x divided by delta T equal to 18 meters divided by 3 seconds equal to 6 meters per second. And a quick important note on units. So it works the same as numbers. So as we can see, we're doing meters divided by second, so it ends up being meters per second. The same as if it was 5 divided by 2. Everything you do to numbers, you do to units as well. So if it was multiplication, if it was like meters times meters, it would be meters squared, for example. So just a general recap of what we went over. So for position, delta x equals x2 minus x1. And I just want to note that our variable x depends on our coordinate system. So it can be like y, it would be y2 minus y1. And our time equation, change in time, is equal to t2 minus t1. And the average velocity is going to be the change in position divided by change in time.